Hey, what's up? This is Zack here with John Woods from Algorand Foundation. Is that correct?
It certainly is.
It's great to be here with you. If you want to give a quick introduction and talk about, what you're doing here.
Sure. Zach, thanks so much for having me to come and speak with your huge audience. It means a lot to kind of get the message out there. I feel like sometimes in the industry, in the Web3 industry, you build it and you think they will come, but that's not the case. You really have to embrace the marketing side and embrace the side of culture and of media and get the message out there even after you've built it. So thanks for the opportunity to chat. I came here, by the way, on the metro, so I'm a little bit sweaty, and I didn't have my makeup done as they did in CFC. So hopefully I'm not too shiny. I'm John Woods. I'm the CTO at the Algorand Foundation, and CTO essentially is the person in the foundation who is responsible for all of the tech divisions, so all of the techie things we do. And in my role, the kind of pillar points are developer tools. So I care deeply about those, and we look after them in the CTO office. DevRel. So that's our developer relations army that's out there helping people build and really being stewards and guides for people, or Sherpas, I like to say for folks that are building on the platform. Infrastructure, which is really all of the nodes and relays and cloud computing that the network needs. We try to maintain stable releases, make sure that we're supporting people as releases roll out, that kind of stuff. And then finally, we have a small but distinguished engineering division. Traditionally, foundations don't really have their own in-house engineering. That tends to be at the inks or the labs, as they're sometimes known. But because I came from a background of protocol engineering at Cardano, and previously before that working on Ethereum at Consensus, naturally I'd always led engineering teams. And so over the last kind of 2 years or so that I've been at the foundation, I think I've rubbed off on some of the rest of the management team there, and they've seen the value in having some in-house engineering. So one of my great colleagues, Bruno Martins, leads out engineering at Algorand Foundation and takes down all kinds of cool little projects, but also gets involved in some proof of concept stuff. So at the moment, he's working on some very cool account abstraction using Face ID to sign transactions through smart contracts on the Algorand network, or even things like equivalent to Sui's authentication product. Building proof of concept around authenticating with regular Web2 websites using your Algorand credentials.
That's absolutely amazing. And what a journey to get here. And I think for our audience who hasn't heard from you before, could you maybe talk about that journey? Because it is a fascinating one, kind of like you mentioned, from Consensus to Cardano and now to Algorand.
Absolutely. So maybe, super quick, so I don't pull out my CV or resume and start going through it. Essentially had a degree in computer engineering. Went to work for Ericsson, the cell technology company. They build both cell phones and also the RNC UTRAN networks that run the global cellular networks. Great experience writing code in C. Had a little while working in foreign exchange, as a forex trader, and I worked in the derivatives industry in London for a number of years. But again, on the math and software engineering side. And then moved into the European Central Bank for a while. I actually led out. I was part of the team from Ireland that led the Euro digital ledger technology proof of concept. So they're building the kind of digital euro very early 2017 kind of time frame. And then moved into my professional crypto career, where I've worked on.
And what year was this?
I reckon like 2017. Yeah. I remember this because it was like the 2016 bull market, where Ethereum was like maybe 2015, 2016, entering into the bull, where Ethereum was like $9, and I was like trying to convince people I worked with in the central bank to buy crypto. And then I was there for about 2 years before I moved on. So yeah, I reckon 2017 moved into Consensus, where I led software architecture and applied cryptography. So that's really, not really writing the code anymore. It's more like, what are the building blocks for this system that we're going to be building and trying to sell to banks and sell to other institutions that want to see operational efficiency increase by using technologies like blockchain. How do we build out? What are the various primitives we need? and also with an eye for security and cryptography. So leading out applied cryptography, which is taking cryptographic elements and building bigger systems with them. That's what I did at Consensus. And so I wasn't on the Ethereum protocol engineering side there. Instead, I was, the Consensus biz dev team were out selling the idea of blockchain to institutions. Those institutions would come back with requirements and say, hey, maybe we could be more operationally efficient in our post-trade settlement, or in our insurance letters of credit, or in our whatever thing that a bank does, if we employ blockchain here. And then my team and I would go and build that and dispatch it to the clients. Finally, then, I guess, in the role that I was in just before joining Algorand, I was working with Charles Hoskinson and the team at IOHK, which is the Cardano Inc., the Cardano engineering group. And I was the lead architect, chief architect on Cardano. And so
for everyone who doesn't, can you talk about that? That's a huge deal.
Yeah, it was huge. Yeah, it was really interesting. I don't know how I first met Charles, but at one point we talked about me working on Midnight, which was his one of a new coin that they're launching, or a new technology they're launching, and it's privacy focused. And I didn't take that role because I just didn't feel like, at the time I was working at Consensus, and I thought, I don't think this is the right one. But then about a year and a half later or so, a recruiter reached out and said, hey, would you be interested in leading software architecture for Cardano? And of course, it's I think a very important project and a very distinguished and sophisticated piece of software. And I think they've done an excellent job with it. And of course, at this point, it was already up and running.
And what year was this? Sorry, just
to
track it, 2017?
Yeah, I guess quite literally 2 years ago, because that's when I left and I was there
for
the previous year. So yeah, what year is it now? 2024.
So 2017 through 2022.
Yeah.
Cardano.
No. I was Consensus for 2 years. And then
Consensus 2 years, and then Cardano.
Then Cardano, and now here.
Wow. Okay. Wow.
Yeah. And it was great. It was an amazing time, man. I learned a lot. I thought I knew most things going into that job, because you get confident. You're like, well, I've seen most of the languages. I've seen most of the things we build with, the message buses, the queues, the databases, whatever, the algorithms. I've seen all the cryptographic primitives. I know all the digital signature types, blah, blah, blah. And you think, oh, I'm comfy now. Hopefully this will be fairly simple. Cardano is not simple. So it was a baptism of fire, and the incredible engineering team there, under Duncan Coates, who was the previous architect, trained me very intensively. But it was wonderful. I learned a ton of stuff, and we did some great enhancements to Cardano while I was there, both in terms of changing Plutus, the underlying smart contract execution platform, making the block size bigger, speeding the network up, working on fee market techniques, looking at things like that are going to be rolled out soon, like Ouroboros Laos, so this idea of input endorsers. So a lot of amazing work. Sorry, I'm not saying my work was amazing, but a lot of amazing work that was ongoing at IOHK at that time. And yeah, it was really, really great. And, I wouldn't be in the role that I'm in now if it wasn't for the role that Charles had given me at that time.
And what kind of made you want to join Algorand?
Yeah, so, of course I knew of Algorand, given its prominence in terms of the pedigree of the team behind it. Folks like Chris Picart, the engineers at Algorand Technologies, Silvio, etc. And so there's a lot of Tal Rabin. There was lots of kind of famous names and very, very accomplished people working on Algorand. And also, fundamentally, it has some incredibly rich distributed systems engineering. So you look, it's all open source. You go to a website like GitHub. You can browse the source code. You can look at the work the engineers have done. You can look at the cryptographic engineering that the cryptographic engineers have put in place.
Why is that important?
Well, it's just important that I want to be working on stuff that's meaningful and stuff that is substantive. And so Cardano was an easy choice to take that job, and because it was.
I guess I sort of mean like. Yeah. For people who don't understand the tech side of what you just said.
Oh, sorry. Yeah, sure. So I guess before you take a role in any company, you check it out. And
a lot of our audience isn't devs, so you may need to break it down a bit.
Yeah, totally. So, before I took the role as kind of a chef in the kitchen, I wanted to taste the food. Wanted to see kind of the quality of the team, whether there was a vision. And certainly both at Cardano and indeed at Algorand, that's certainly there. And, you don't want to join. There's an expression in technology, vaporware or this kind of stuff, like as in software that's like just like an idea and not actually running. And so really important to join a team that's behind a product in any capacity, whether that's an iPhone, a Tesla vehicle, or indeed a piece of open source software like Algorand or Cardano. You want to be joining a team that's delivering a quality product, and make sure that, like, when you look under the bonnet, that everything is working in order. So again, when I look through that source code, when I look through the engineering and even Silvio's pioneering work around VRFs, these verifiable random functions, which are a piece of math and cryptography that's at the heart of both, actually, Cardano and Algorand, was invented by the founder of Algorand, just incidentally. And so technologies like that excite me, and it was great to join a team of that pedigree.
If you could talk about maybe some distinguishing factors of Algorand that I think our audience would be interesting to know.
Sure. Right. So this is kind of a 45-minute answer, probably.
That's fine.
But I'll
take
try
as much time as you need.
I'll try to squeeze it down. So to break it down simply, all of these cryptocurrencies, Bitcoins, Ethereums, Cardanos, Algorands, etc., they are essentially distributed networks. Okay, so what does that mean? It means there are many computers, physical computers, running all over the world that are running the same piece of software, and those pieces of software are interconnected to each other. And so this is not new, right? We see this all the time. This happens when you're playing video games, when you're playing Doom Eternal, or you're playing, I don't know what's cool right now, but like when you're playing Counter-Strike 2, your computer is connected to 9 other people's computers when you're playing that game.
PvP, a LAN network. Yeah, right. Yeah, totally. Okay.
So this stuff is not new. This idea of computers connected to each other running the same piece of software is not a new idea. What's new is that on these blockchains or cryptocurrency networks, there's some extra magic added. And that extra magic is this idea that rather than just, playing a game where we don't really check that everyone is obeying the right rules, right? Because you can have cheaters in video games. In these cryptocurrencies, they're all playing the same game, they're all running the same code, but they are using cryptography, so the art of mathematically verifying and mathematically protecting information. They're using those mathematical techniques to ensure that everyone's copy of the ledger or the blockchain, which is like the list of balances for people's accounts, is kept with a high level of veracity and correctness. So that's the raison d'etre of these. It's there I am in France with my French.
Love it.
Yeah, thanks, mate.
Bring it out.
That's the kind of like the whole reason they exist. Okay, so most of these blockchains will say, except for maybe Bitcoin and Ethereum, most of them will say, I'm green. I don't use a lot of energy. I'm fast.
Fast, green, cheap.
Fast, green, cheap. There you go. Scalable. That's another one they love to throw in. Secure. Another one.
The network doesn't go down.
Right, network goes. Yeah. Slowing up.
Yeah, no, I knew. I was like.
So you asked, what separates Algorand from the pack, and I think it's hard to distinguish oneself when you're in a pack of competitors, because it is a highly competitive market. When the iPhone came out, it was kind of the Nokia, whatever, E65 or whatever it was, I can't remember at the time. And it was like, or BlackBerry, there wasn't really a lot of beautiful glass slab phones that did smartphone things.
People were like, what is this?
Right.
Yeah.
Right. Whereas now, I think, in the Web3 industry, there is tough competition.
It is.
Yeah. And a lot of these chains do things right or are good at particular things. And so what distinguishes Algorand? I think we've got a number of unique properties. So the first I will say, and this is not like kind of the one that's rolled out a lot when people ask this question, but we have a team of world-class engineers and world-class cryptographers and applied cryptographers. And so what does this mean? It means we have the Ronaldo and Messi of crypto and math working on Algorand. It means we have, the Gordon Ramsay, or I don't know who else is cool. What else?
Mr. Beast of YouTube.
The Mr. Beast. We have the Mr. Beast or the Snoop Dogg. I don't know what's cool in music anymore.
Snoop Dogg's always cool.
Is he cool? Okay.
Of course. Snoop Dogg.
Yeah, I don't know what's cool. Like Lil Wayne. I don't know. Is that cool?
Yeah.
I don't know.
Lil Wayne's still cool.
We have like those people working on Algorand. And so what does that mean? It means what is the result of that? Answer. we have cryptographic techniques that started with Algorand that are used by other cryptocurrencies. For example, the VRF, the verifiable random function. Of course, if you're not a developer or mathematician, that's not going to make much sense to you. But it's a thing. It's a thing. It's a piece of math you can use to achieve consensus. It's not only used in Algorand. Other cryptocurrencies were like, whoa, that technology is cool. And so, for example, quite fairly and quite rightly, because it's all open source, you're allowed to do this, Cardano uses the VRF that Algorand's founder created to achieve consensus and a leadership schedule on Cardano.
So they basically integrated that after seeing Algorand utilize it.
Right.
Interesting.
Yeah.
Okay. That's cool.
But again, they use it in a totally different way, but they use it for an important part of their consensus. So that is, keeping the blockchain in sync, which is the heart of these cryptocurrencies. And so that's one example. People working on Algorand invented this stuff, right? They're not just kind of remixing it; they're inventing it. Secondly, maybe another kind of, impact of having that kind of caliber working on the product. We are one of the only chains out there that has any kind of post-quantum security. And so, again, there's a lot of background.
No, that's very interesting.
I think so.
Yeah.
I think so too. And so, a lot of these things I'm going to say, they require, a deep knowledge of a bunch of different things before you can maybe internalize, the impact of them. But just to say, right now, most computers in the world are these normal computers that we've grown up with. There's a new class of computers, quantum computers, and they harness the power of quantum superposition to achieve kind of parallel processing. That parallel processing is not good at everything. It's not going to speed up Counter-Strike, but it's very good at breaking certain mathematical problems, specifically the discrete log problem, which is what most cryptocurrencies base their inforgeability on. Mm-hmm. So the idea that you can't forge Bitcoins is based on this idea of these digital signatures being strong.
That's so... It's like, it's coming. Quantum computing is coming.
Right. You see, people don't really truly know because it's like a little bit speculative because it's an emerging area of science. No one's actually done it yet. There's, the articles quoting quantum supremacy, which is where quantum computers done something, profound. We're still, it's still in its infancy, but, it's real. And I know it's real because, agencies around the world like NIST, the Institute for Standards and Tech in the US, government agencies in the UK, and I'm sure all over the world, are actively standardizing cryptographic techniques for government use that are resistant to these quantum attacks. So they're assuming these things are coming. Then I look at consumer products, Google, Apple, etc. Google have added Kyber, a post-quantum algorithm to Chrome. They're not adding post-quantum crypto to Chrome's code base just to complicate maintenance and spend money on mathematicians. They're doing it because they think it's going to be something they need to do. Apple added it to iMessage. They called it PQ3. You can Google it, iMessage P, for Papa, Q for Quebec 3. And you'll see Apple have just added all this post-quantum math to iMessage, the blue bubbles. They did it. They changed the blue bubbles under the hood because they're thinking about this. And so Algorand has a form of quantum security we employ for people who want to have a look at it in more detail. Falcon, which is a lattice-based post-quantum signature scheme. And this Falcon signatures, these digital signatures that are immune, supposedly, based on our current understanding of how quantum computers will work, they are immune to attacks from a quantum computer, where a quantum computer will run a very particular algorithm known as Shor's algorithm to solve the discrete log problem. So they're immune to attack from these quantum computers. And so, in the morning time, if there was a new quantum computer, Algorand's chain history, all the blocks that are in Algorand's blockchain so far, are safe. In contrast, those in Ethereum's and those in Bitcoin's are not. And so again, you only get these types of things when you have world-class people, because it takes world-class people to even begin this journey. It's just too hard to do if you don't have those type of people on staff. So that's maybe somewhat intangible, but I just wanted to mention it in terms of the hard differences. Algorand has instant finality, and so a lot of people and advocates and evangelists of different blockchains will say, well, finality is pretty fast on platform X, on platform Y. Finality is near instant. But in Algorand, it's mathematically near impossible for the blockchain to fork. And so this is really, I think, our secret sauce. When I was working in consensus, I was working on big projects from major banks. And one of the problems with Ethereum, and it's not like a showstopper, but it's an acknowledged and understood kind of thing that happens, is that on Ethereum sometimes you'll have blocks in a blockchain, and be like block 1, block 2, block 3, everything's cool. Block 500, right? Here we are now a little bit later. And you'll have all of a sudden a short fork in consensus. So you'll have two different kind of like the blockchain will split into kind of a two-headed snake, right? And for a little while, you'll have 501A and 501B, 502A and 502B, 503A, 503B. And at some point, one of these chains, one of these kind of the split will get longer and longer. And when it gets long enough, most of the network will look at the shorter one and go, that was wrong. Let's jump onto the longer one. Now, this is normal. It's called a block height battle on Cardano. It exists in Cardano. It's called a short fork sometimes on Ethereum. There's other names for it.
What happens to the user's transaction?
Block reorgs on Monero is what they call it. Say again?
What happens to the user when their transaction?
Right. So this is critical. So, I mean, this hasn't happened to me very often, but I remember once I sent some Monero to a friend. We went out for some food, and I said, you pick up the tab and I'll pay you a Monero, whatever. I'm trying to encourage use of this stuff. It was years ago. I sent him 8 Monero at the time, which would be like $800 now, which is too much for a steak. But anyway, I sent it to him, and when I got home, my balance had gone from, say, in the restaurant, it went from 38 Monero down to 30. When I went home, it was back at 38, and I was like, "Oh, that's weird. I thought that sent." What actually happened was it did send. It went into the mempool. The transaction was propagated across the network. Things were good, but it was on the wrong side of history. It was in one of these short forks. My transaction was rolled back, and so they call it a rollback. And so this is, happens on every cryptocurrency that I've seen, except for Algorand. And why? Algorand doesn't have these little disagreements. Algorand's consensus, which is known as pure proof of stake, which leverages these VRF things that I spoke about earlier on, this mathematical thing that Sylvia came up with, ensures, from a mathematical standpoint, like cryptographically, with like, nearly absolute assurance, like 99 point a zillion nines, right? That all participants in the network agree on the next block every time.
How does that work?
Yeah, so I got asked this the other day on a Twitter space, and the answer is by running the VRF a number of times, by selecting committees, by essentially taking the output of the VRF, which is non-biased, and then biasing it through a binomial walk cumulative distribution function. It's quite a complex mathematical thing, but ultimately what you're doing is you're essentially saying, out of the sea of participants who are making blocks, with a weighted probability based on their stake. So if you've got one coin, you're like a little bit of a probability. If I've got like 1 billion coins, I've got like a ton of probability. You'll be selected based on that probability. And when you're selected, and you can prove that you were validly selected by the network, you can propose a block. We do the same thing to kind of whittle the blocks down to kind of a perfect block, and then we do it one more time to add it to the chain. By doing this thing, using binomial walk, using the CDF, using the VRF, using these mathematical things, by doing this process, we've achieved a consensus mechanism that never has disagreement. Everyone, 100% of the network, agrees on every block. And why is this important? This is important now, coming back to the answer for the question, what are the differentiating factors for Algorand? It's important because it means you don't have to deal with rollbacks. When I went home that night, I just sent the transaction again because I care about my friend. But that doesn't happen in the real world. In the real world, if someone sends some Bitcoin and it's in a short fork, or someone sends some Cardano and it's in a short fork, that person's just fortunate. If you've already left the cafe and you've already got the iPad, that you were buying secondhand, how many people are going to send again? Maybe some if you're honest, but not everyone. And for business, that's retail. For business, this is even more important. When you're building enterprise-grade applications, you always want to make sure that you're building solutions that are elegant and simple. You tend towards less complexity because it's easier to maintain and it's less chance it's going to fall over, like Solana. That was a joke.
Yeah, why? What do you think about Solana's growth?
I'll come back to it in a minute.
Okay.
The growth is unsustainable. But when you build these apps, you want to keep it simple. And so if you have a blockchain that has short forks like this, unlike Algorand, you've got to put in a transaction orchestration layer. You've got to put in software that helps manage replaying transactions that are rolled back. And so that is, I think, one of the most wonderful differentiating factors for Algorand. It is truly final the second a transaction's in a block. So it's instant finality. And indeed, of course, we have other things that are great. We've got over 11,000 TPS at the moment, which is more than enough to meet up demand. We have a fee market which is genuinely extremely cheap. It's like fractions of a fraction of a cent. In fact, I think the fees need to increase, to be quite honest, because I don't think it's sustainable to have fees that are that low. They should never be tens of dollars or $5 or
yeah.
But like, should fees be a couple of cent? I probably think so in a sustainable economy. And then, we have some incredible developer tools and other things, but that's, I think, the big differentiating factor. It's a hard, tangible difference, and I think it's very important.
Okay, so I'll go back to the other question. Solana, like, what do you think about the growth of Solana? Because you've said some things online. I think this is interesting.
Yeah.
This will get the views, the clicks. What do you think about, like, the growth and your comments online and stuff? Like,
yeah, I
thought it was hilarious.
Yeah, I think it's funny too. I like to poke Merton or whatever his name is, because he's so full of himself and he says he's really rude to people, and I just don't like him. That's the truth of it. And like, they say so much stuff. You can't tell me in any reasonable way that having 75 to 80% of the transactions on the chain just bloat out the chain and waste resources is an elegant design, because it's not. Explain
what that means.
Yeah. So, I mean, right now there's some kind of conversations around Solana. A lot of people are asking questions on a daily basis on crypto Twitter or crypto X, whatever it's called. They look at the number of transactions that are being processed by Solana, and they look at the number of transactions that are successful. Okay, and what success means in the context of a blockchain is has changed state, or has created a side effect. Okay, so success is money leaves my account and goes to yours. Success is you interact with a smart contract and the smart contract ran to completion. 80% of the transactions on Solana, well, maybe I'll be fair to them. I think it's like 76% of the transactions on Solana at the moment. Last time I looked, as of yesterday, so April 9th or April 8th, 2024, were failing. So they were running to some percentage of completion, but not 100%, and thus were not creating side effects. They were not creating any change to the state of the ledger. Now,
so they weren't settling on chain.
Right, they weren't settling. And so what most Solana proponents will say is that this is okay. This is normal. Look at your desktop computer. Isn't it the case that sometimes programs will error out on that? Like, you could run a Python script on your computer, right? And sometimes it will have an exit code that's not like 0, right? Sometimes it will exit with a code that's an error. Sometimes you run your computer program and it says error 15. Sorry, not enough disk space. Sure, that's fair. In computer science generally, we do want computer programs to be able to terminate, not run forever, to terminate, and sometimes tell us a reason why. I'm out of memory. There's not enough disk space. I don't know. I lost some power, whatever. These are okay. This makes sense in a desktop. It doesn't make sense, in my view, in a decentralized network where bandwidth and resources are incredibly constrained, because on all blockchains globally, you want the chain to grow as little as possible whilst doing the most work. You also want to be able to process as much as possible to meet all your users' demands. You don't want anyone waiting, et cetera, et cetera. So, in all blockchains, it's fair to say you want to minimize resource use and maximize impact and value for your end users. And so, I don't accept that in a blockchain context, this traditional view of computer science where, hey, programs can sometimes terminate ungracefully or in a way with an error code, that doesn't make sense to me in a blockchain. And I think most importantly, it's not in a normal computer when something errors out or comes back with an error code 17, I couldn't get the key, that's okay. On a blockchain, you still have posted all the information to the chain. You've still had computers globally run code not successfully to completion. You've still added the transactions are still added into the blocks. So you're bloating out the chain. So that data, that effort, it has not resulted in any benefit to the user. So that to me is not good at all. And you might say, well, how come Algorand doesn't have this problem? I mean, what do they do? What Algorand does is when a transaction is submitted to the Algorand network, it first meets one of the computers on the network that I talked about earlier on, these computers that are globally decentralized. It meets one of them. And that computer will check the validity of the transaction. It will deterministically, or without kind of chance, it will check, hey, will this thing run to completion? Is this thing good? And only then will it allow it to propagate across the network and be run and captured in a block and executed by the rest of the computers in the network. And so I'm teasing them a little bit with, I made a meme and I said,
I saw that.
Yeah. The smoking my baby failed transactions are useful. I can see their point from a computer science point of view, from a computer engineering standpoint, being very technical about it, or very, very, specific about it. But like in the real world, practically, not good. And then so they talk about transactions per second. I think Fire Dancer is an interesting one. Jump or whatever, working on Fire Dancer and talking about 1 million transactions a second. That's going to bloat the chain. Like if indeed they are successful with this millions of transactions a second, it's going to bloat the chain by terabytes to petabytes a year, right? And so this is unsustainable. If you've got nodes that are growing by four petabytes a year, right? This is like your MacBook at home has a 1 terabyte disk, right? 1,000 terabytes is a petabyte. So you need 4,000 MacBooks to 4,000 MacBooks to store 1 year of Solana. I mean, I'm exaggerating at the moment because that they haven't hit that million TPS. So they're not growing at that rate at the moment, but they are growing at an alarming rate. And again, many of your viewers may not think about these things, but when you're looking at it, from an engineering standpoint, is it important to keep the network decentralized? Well, I think so. That's why we started this thing, right? The whole idea was decentralization. Okay, so how do we do that? Well, you have many, many people around the world run these computers, that run the nodes, that run the software. Everyone gets involved, not just like your bank and your government. Okay, cool. How is that possible on a chain that grows by 4,000 MacBooks a year in space, right? I run an Algorand node at home on a Raspberry Pi. And you've got to, of course, computers today run programs that weren't possible to run 20 years ago. That's normal. I'm not suggesting we shouldn't have advancement in compute requirements or advancement in bandwidth requirements or other things. It's normal. But you got to grow with the rest of the infrastructure around you that's available to the common person. And if you don't, that's okay, but you're going to get to a place where you're not decentralized, because to store the whole chain, you'll need a computer in a data center the size of a football field. Now, maybe the answer is, well, we'll shard and consumers will only hold a tiny bit of the chain. And if they want to verify, then they can download the whole thing from, the NSA basement supercomputer. Fine. But then at least be authentic with that, because that's not maximally decentralized, is it?
No, it's interesting.
And so, these are my thoughts. Of course, it's very hard to articulate all this on Twitter when you're arguing with Mert and his army of disciples, maybe. But, these are the things that I think about. And I think we try to be intellectually honest about things.
Do you think, I guess, like for people who are just learning about Algorand, and your new developments, as we kind of chatted as you came in here, I'm obviously wearing an Algorand t-shirt, so
I paid him.
No, you did not. I'm just very supportive, and I think it's interesting. I also helped list it when I worked at OKX, so I got to deep dive in and read about all the technology as we were listing it to evaluate it. So I didn't obviously go into deep, but I know now that we're talking about Python and Teal script and these different things that are making it more accessible. Do you want to kind of chat on that?
Yeah, sure. I'd love to. And by the way, I should have worn my Algorand t-shirt too. I at least should have come in a cap or something.
Let's go. We'll throw a logo on.
Thank you. Yeah. You just digitally put it here. Thank you. So yeah, coming back to just to disambiguate where I'm coming from on what I'm about to say next. These blockchains, we talked about how they're globally distributed networks of computers running software. Essentially, what is their reason? What's their value? Their value is they can run applications, but rather than running them like your cell phone does, just local to you with one copy, it runs globally on the entire network at the same time. And so, why is that important? It's important for certain classes of application that you just can't do on a cell phone on its own. Those classes of application are ones where you need a root of trust, where you need to be able to have a decentralized ledger where balances can be trusted by the entire network, by everyone globally, where you need to be able to mathematically verify people's balances and transactions, where you want to, disintermediate, centralized entities, where you need provenance or veracity of goods and services. Those types of applications really are great on blockchain. So blockchains are like an operating system, just one that's very suited for a particular class of application. And so, like all operating systems, like your cell phone, like your desktop computer, we need to make it easy to build apps. On the desktop computer today, building an app is totally different to what it was like when I started learning computer engineering as a young person. I started on DOS 6.2. I started using BASIC, the programming language. It was very rudimentary. There was no linting. There was no
Wix.
Right. There was no Wix. There's no WYSIWYG. There was no
drag and drop,
CI/CD. Yeah, none of that stuff. There wasn't even Stack Overflow. You couldn't there was no ChatGPT. You couldn't be like, give me a Python function that does X. And so, no, it's fun. And I obviously didn't do very much in that environment because it was very hard to progress. But if you look today, what is it like building writing an app for a cell phone or writing an app for a desktop computer? It's a really, really low barrier to entry. Anyone can do it using a relatively simple computer. There's resources all over the internet, videos, content on not even just like the stuff like Udemy and Coursera or whatever, but just like YouTube has free stuff. Stanford posts the courses. For free, you can ask ChatGPT 3.5 questions that you would get answers like a professor at a university level. It's incredibly great. And so, as well, another thing is the languages are mature. So if you're building in Swift or Kotlin or even Rust or TypeScript, it's super easy to build apps on desktop. And so I really wanted to take that experience and bring it to Algorand because it is an operating system and it does need apps. And so Algorand wins when it's rich and vibrant and full of apps and full of users. And so you gotta give developers the tools they need to build that playground. And so when the team and I started looking at the developer tools, which was, I guess, one of my primary focuses when I joined, because it was recognized that, sure, the protocol is great for all the reasons I said earlier on, but the dev tools
doesn't mean it's easy to use.
Yeah, it's not easy to use, right, for a developer. And sure, there was some really smart people that just figured it out and brute forced their way through, the hard.
There's always going to be a small subsect,
right?
But you need everybody else,
right? We had the John Carmacks that just make Doom in his bedroom or whatever, but for everyone else, they need help. They need the Unreal Engine. They need to be able to be given tools to achieve things in a reasonable time frame at a reasonable cost. And so, the language of Algorand was Teal. When we had a funeral for Teal. Thank God it's gone. Teal is a low-level assembly language. And what this means is you're kind of talking directly to the Algorand CPU. You're kind of saying, hey, CPU, add these two numbers for me. Hey, run this code. I need you to verify this particular string of bytes. That it's fine, but that's not a way to express yourself when you're trying to build a business logic for your app. If you're building the next Folks Finance, which is, our one of our big DeFi venues, you need to be able to think like someone who's building a DeFi app, not like a computer scientist. So you need to be able to have a mental model for how your application works, not down at the ones and zeros, but up in terms of objects and resources that make sense to interact. So at your user level, how do users interact? What does a trade look like? How does a swap look? Not lower than that. You need to be at that level. And so to achieve that, we have moved away from Teal, and we have brought rich and full support for so anything you could do in Teal, you can now do in Python. And so we've brought one of the most inclusive, simplest, and I think when it comes to startups who don't have a lot of money, naturally startups tend not to be flush with cash. They want to hire developers as cheaply as possible. They want to get to market to see if their product is going to work, their business is going to work.
Most common coding language, whatever is easiest. Yeah.
Right. So what do they write in? They write in TypeScript, JavaScript, Python, right? I mean, that's essentially it. And so we needed to give them the tools they were already using. We needed to meet developers where they were. And so we moved away from Teal and PyTeal, all these low-level things, and we've now moved into regular, semantically normal Python. And so this is really important. Many platforms out there, and I think just to pick on one, Ethereum, Solidity is essentially JavaScript, but it's not really. It's a flavor of JavaScript. Viper on Ethereum is essentially Python, but it's not really. It's a flavor of Python. It's kind of a colored version of Python. And that means that it's not normal Python. When we built Python on Algorand, we wanted to make sure that we brought regular normal Python so that all things that make sense in Python normally on a computer make sense when you're writing an Algorand smart contract. And so, of course, there are things that you literally cannot do in a smart contract. You can't make web calls and you can't parallel process things and other things like that. That's common to all blockchains. But all normal Python syntax can be executed within an Algorand smart contract. And this is critically important because this means that you're not just in a weird Algorand version of Python, you're using normal Python. And why is that beneficial? It's beneficial because the folks that come from existing businesses, existing Python developers, which are these people who are cheaper to hire for your startup, they're cheaper to have on staff to maintain your product, get you to market faster. Those folks don't have to learn new syntax. They don't have to learn new rules, new bits to the language. It's just the language they know.
Get him out of college.
Right. Yeah. Get him fresh. Get him cheap. And I think most importantly, because it's syntactically and semantically regular Python, you can use existing Python libraries. So there are libraries already. There are resources, there are tools that exist in the Python world and have existed before Algorand existed. And you can use some of those tools where it makes sense, of course, in a smart contract, to do things within your smart contract and to test your smart contract and to make your development journey easier. So this is really, really great. And so the transition away from Teal and PyTeal to regular Python for all app development on Algorand has been, I think, one of the most important things we will probably ever do in terms of the developer tool suite. And by the end of this year, moving towards kind of spicy alpha here, AlgoKit 3.0, we're going to be adding another language. And that other language is TypeScript. So we're going to be adding full, rich, semantically normal support for regular TypeScript. So TypeScript developers can now, by the end of the year, will also be able to build their apps and their vision on Algorand without learning anything new. And on top of that, we'll have rich line-by-line debugging. Again, some of your viewers may not know what that is, but when you have bugs in your code, you'll be able to step through line by line in a very, very rich visual way and get rid of those bugs. So again, reducing costs, reducing time for debug, reducing go-to-market overhead. And so we are in a great place when it comes to the developer tools, and it was a long time coming. So I'm very excited to see the types of things that will emerge now that we've essentially smashed the learning curve.
The barrier to entry.
Doesn't it? Yeah, the barrier to entry doesn't exist anymore. It's like football now. You just pick up a ball and go to a field. You just pick up Python and you pick up your computer and you can go. And so I'm extremely proud of what we've done. It's only going to get better, but it's now easy. So please go and give it a shot.
What are some applications you're seeing build that you think are cool?
So, I think with all wonderful developers, with all kind of very highly skilled developers, we've seen people build, incredible things on Algorand even before this. But again, it's not about having, say, the top 20 developers in Algorand achieve what they've achieved. It's rather so that we can have the next 1,000 achieve it without having the learning curve. The language is only being released in the last couple of weeks, so it's only out in people's hands for a little while. But already, I'll give you a couple of examples. A number of the community have started just making tutorials, right? They've just kind of like, hey, I thought I'd play with this thing and I wanted to see how good it was. And here's my attempt at doing something interesting. And one I would like to single out is an individual called Alexander Codes. That's his online name, Alexander Codes. And he implemented a simulation of Bitcoin. So he essentially wrote a contract using just Python that was able to issue an asset on Algorand using a smart contract where you had a proof of work mechanism and it simulated the work of Bitcoin and it simulated the emission of coins a la Bitcoin. I just thought it was an interesting thing to be able to kind of simulate a Bitcoin inside Algorand using Python We've also seen one other thing I'll touch on. Again, these are small.
No, the Bitcoin thing is super cool.
Yeah, it's cool. If you just type Alexander Codes, you'll get his blog, and he's got it right there. It's really great, and it's really visual, so the way he's presented it. One other item I'll just call out again, because this stuff's only in production in a couple of weeks. So, we've been telling people to stay away from production apps because we want to make sure it's good before we tell you to use it for real things. So that's only been like the last couple of weeks. But our DevRel team that I mentioned maybe at the very, very start of our chat, they've been working on some coding challenges to get people excited. Like, so, hey, you win this NFT, you win this prize. If you can manage this coding challenge, here's the code, git fork it, git clone it, make a fork, make a PR, and submit it. And so we've seen people who are not developers, people who will go out and tweet and, at me or tag me or whatever, tag our DevRel team and be like, I just couldn't do this. I couldn't get Algorand started prior. I couldn't get the developer environment set up. Now I had the developer environment set up, and you know what? I figured this little bug out, and I feel great. And so that is exactly where we need to be. And you might think, does it matter because aren't big institutions like banks, Bank of Italy, Citibank, don't these people just have incredible developers on staff that'll just figure it out? Well, maybe, but that's not, going to get us to a place of real world adoption. To get that real world adoption, your network's got to be up all the time. It's got to be reliable. It's got to be easy to use. And people have to have fun when they're using it. And so, yeah.
What do you think that maybe people miss about Algorand who are in other ecosystems, or just things that you wanted to kind of share?
Yeah, so I think a lot of across the industry, I think a lot of the various chains have very devoted users. I've never been a maxi on anything really. I mean, I'm a bit of a privacy maximalist, so I am a bit maxi on Monero a little bit as in terms of privacy coins, but in general, I try not to be too tribal about things. Because Solana's cool in its own way, right? It tries to harness all of the compute power of the computer to have massive throughput. I mean, AVAX is trying to do something with co-chains and subchains and things like that. Cardano is deterministic. It's using EUTXO. It's not using an account-based model. So UTXO allows you to do a lot of parallel work in a transaction that's just not possible on account-based chains. They all have a lot going for them, and so and so I can understand why people are so tribal. It's a bit like football clubs, in the UK or whatever, where it's just like, I'm Chelsea till I die.
I mean, it's very interesting us running this media house because we have all different chains. Everyone come through because we're open to everyone. So, no, definitely. I think the tribe. I agree with you. I'm not part of any certain tribe. I think we all should work together. We're still Web3 versus Web2.
Right, but I would say that so I agree with you, and so I would like to see less tribalism where possible. I would like to see less totalitarianism, if that's the right word, about maximalism, about these chains. We should be using the tools that are best for the job. Of course you're passionate about it when you're a long-time user or you're engineering the protocol or whatever. Of course you do. But I think it's important just to remember that we're all trying to push in a particular direction, and that direction is away from a place where our only option for executing code was in a centralized capacity, or our only option for an identity was from a government, or our only option for using a currency or a node of value that was transferable was using a government currency. Not that there's anything wrong with those things. They're great in their own way, but it's great to have options. And if I can have a way to use money that doesn't depend on a government, or isn't impacted by seigniorage, isn't impacted by quantitative easing, isn't impacted by whatever government's in power. If I have a way to have an identity that I don't have to wait for the passport office to issue it to me, and I don't have to wait till Monday morning because they're not open on a Sunday. And these things are important. It's important to have decentralized options to things. I really do think it is. Just like, by the way, it's important to have decentralized options to messaging. I don't just use iMessage. I also use IRC, which is a decentralized federated messaging client. I think these things are important. But yeah, to answer your question, what maybe will people feel or see if they were to try Algorand? I think from a user point of view, a sublime user experience. And so what do I mean by that? I mean, when I first picked up my iPhone, installed like the Algorand kind of core wallet, which is called Para Wallet, and I funded from Kraken, which is an exchange I use. I funded like, I don't know, 100 algo or something like that. It's like $20, whatever. I was like, that's weird. I must have got straight into a block, It's like, I can't believe that's there. Like, I mean, a lot of networks are fast, but like, it was like 3 seconds or something. I was like, I must have been lucky, because I hadn't looked at the block time yet. I was just flirting with the idea of working on this thing. And then I realized, no, this is every time. Every time I post a transaction, I see the result within 2.7 seconds. That is a compelling thing. It's compelling that I can move this money back and forth, and I can trade on Tinyman, I can trade on Pact, I can trade on Folks Finance, and I have, it's so fast that I have next to no slippage. It's incredible. And when you're showing, people who are not from the industry, when I'm showing my brother or my father who doesn't work directly with these technologies, so they're like, they expect things to work like this. Mm-hmm. Like when I Revolut people money or whatever, it just goes through. They expect it, and they're like, "Why are you excited about this?"
Yeah,
this is
But
normal.
like, I mean, but asking if they send a wire transfer,
right?
International, it's not the same. Like, I totally hear you though.
And so I'm focused very much on the user experience. So whether it's that kind of just like core user experience of sending a token on the protocol, or whether it's the experience you get with our DevRel, which we've built a team who give like a concierge. It's like you're staying in a 5-star hotel, right? It's like nothing is too much trouble. You get line by line level support for your code. Or indeed, whether it's just the ecosystem we have. So we've got such passionate community members, many of which, I won't bother mentioning them because then I'll leave someone out, but many of which just live and breathe this stuff just because they think it's important from a financial inclusion point of view. So I think there's some of the things that people might enjoy over here, but like many other communities, there's good and bad.
Can you talk about maybe just like where you see the future like of Algorand going, and some different things that you guys are doing maybe here in Paris too?
Yeah, sure, absolutely. So actually tomorrow night we have our event, which is called A Night in Paris with Algorand.
We'll be there. Yeah,
excited,
awesome.
Excited to have you guys there. I'll have a beer with you. And so we did it. This is my second time I think going to it, so that'll be good. Tomorrow afternoon, Silvio's speaking, so looking forward to catching up with him. I think though, if I look kind of further ahead, what are the kind of things I'm excited about for Algorand? Beyond the kind of core stuff we're working on in the protocol, because we're looking at like post-quantum for next year. We're looking at what's a post-quantum VRF look like, what's a post-quantum signature scheme look like. We're looking at how we can improve our recent. We changed the speed at which kind of, without going too technical, we increased the speed of transactions. So we're looking at like what's the next stage there? What is the next advancement around the AVM, which is the CPU at the heart of Algorand? The things that Algorand can do. We rolled out recently support for pairing-based elliptic curves that let you do ZK and homomorphic style stuff within a smart contract. So lots of exciting things there. But I think in terms of the things that I'm most excited about, I would say seeing the things that people do now that they have a regular computer programming language to build apps with Python. Getting TypeScript at the door, because I think it's important, because there's lots of people who, as easy as Python is, there's lots of hardcore TypeScript devs that just love TypeScript, just love JavaScript, and that is essentially all the Ethereum crowd, right? Solidity is basically JavaScript / TypeScript is essentially a flavor of JavaScript, and so all of a sudden, all the Ethereum people can just build on Algorand. Later this year, in late Q2, early Q3, we're going to have a change to the network where you'll be rewarded for producing blocks. And so right now on Algorand, you actually don't make any algo for processing transactions, validating transactions, and creating new blocks. People do it altruistically. People are staking their algo to make another block on the blockchain, but they don't get a reward. And this is kind of counterintuitive because, on Bitcoin, you mine, you get the Bitcoin. On Cardano, you stake, you get the Cardano. So we are making a tectonic shift to that philosophy, moving away from altruistic staking, where we just expect people to stake for the health of the network and to secure their own funds, and moving to a place where people will be actively rewarded by the protocol at layer 1 for producing blocks. And so
That's huge.
Yeah, it is huge. It's huge because it does two things. It moves the network towards further decentralization because the number of nodes in the network will just bloom out. And it also increases the security and the amount of algo that's being staked. And so it's a very important change, and it's dropping this year. And so this is building, I think, as well, excitement around Algorand. It's building kind of like, hang on, there's things happening here. Python's happened. We're going to start getting rewarded for producing blocks. This Algorand is changing and adapting to its environment. It's adapting to its competition. It's adapting to its surroundings. And then finally, maybe just one other item I would just mention. Again, pushing towards maximal decentralization and maximal security. After we do consensus incentives, we're going to be releasing a change to how data flows in the Algorand network. Of course, all blocks are data, all transactions are data. When I say data, I mean any information that flows in Algorand. What is the greatest thing you can do after you've rolled out consensus incentives, after you start rewarding block producers, and you've seen this Cambrian explosion of nodes, so you've got more computers than ever in the network? The answer is you move the way data flows from a relay style network, which is like a ring road or a superhighway around the network, where you've got a small number of computers that are very fast that propagate data and relay data. You move away from that to a place where you exploit, right? You enjoy or leverage, I should say, rather than exploit, because that's a negative word. But you leverage all of those new nodes that are in the network and start using them as kind of like a neural network, like this, like, it's obviously not really a neural network in the AI sense, but like a network of like a really dense number of pathways between all these nodes to roll out a peer-to-peer network. And so we're going to be moving from this relay network to a peer-to-peer gossip-style network, which again maximalizes decentralization, because it means that if every relay node shut down out there, and this is one of Justin Bond's, who's a commentator in the space, clearly you'll know him. But if you look at some of the criticism that's been pointed at Algorand, the two things were dev tools, fixed. Relay nodes, because they're not maximally decentralized. They will now be, by the end of this year, fixed, because you won't need them anymore. If they all turn off, you can just still find a pathway through the dense peer-to-peer network that's going to be there. And so, yeah, we've done a lot, but there's definitely more to do. But I'm very excited about our chances, because I think we have the right people on stuff.
I completely agree. All right, just to kind of come in here as a final, what would you say to people who are at home and are thinking about coming to an event like Paris Blockchain Week? And, how it's been going for you guys? Because, a lot of people watching this will be interested.
Yeah, I mean, I think, I've been to some of the main ones, I would say, over my time working in the industry. I've been to like Token a few times, in Singapore. I've been to Consensus in Austin. I've been to CFC. I've been to a whole bunch of them. But I think Paris Blockchain Week has something a little bit je ne sais quoi. There I am again, you see.
There you go.
Again, the French.
Let's go.
It's good. Let's go. No, it's a very pretty city. The food is wonderful, and it's very romantic. So I think there's a nice vibe around Paris for Paris Blockchain Week. The city has great resources, and in terms of like public transport and stuff. And I think there's kind of a bit of magic in the air. I quite like it. It's probably my favorite European conference. So yeah, it's great to be here. And so for folks that are thinking about getting involved, what I would say is, of course, with Paris Blockchain Week, sure, come and talk to people. I think the Web3 community generally, I don't even like this word Web3, but like the people who are working on decentralized technologies tend to welcome new people, because they want decentralization. They want to spread this message of the important work that they're doing. And so it's a very friendly community, very approachable. And in terms of like, if you're someone who's like, I've heard of crypto, I missed out on it the last couple of kind of times people were banging on about it, and I'm kind of maybe interested now and looking a bit deeper because I didn't do it last time my friend was banging on about it, and then he whatever. What I would say is, yeah, what would I say? I mean, I think it was easier when there was a lot less of these things to look at. I know there's an expression, this do your own research, but it's really hard, right? Because you're looking at it going, well, where do I start? What does do my own research mean? Does it look at like, do I look at like the market cap? What does that mean? Do I look at the supply? What does that mean? I don't know how to speak, read code, etc. But I think there's a lot of great communities around the web. on many social media websites that have people who are really excited about this stuff, but verify what people are saying to you. So like, you know, if someone says X is the fastest, check it out. You know, why is the greenest the cheapest? Check it out. I remember when I was very early kind of getting into my first Bitcoin kind of, experience was in 2012 or so. I was running a node, then kind of found it a bit boring, was after trading it for a while, wasn't doing great with trading. And then I kind of went to sleep on it 2013, 2014. But like around 2015, I started getting back into crypto in a personal capacity, and just was like heavy into kind of like the idea of privacy preserving tech on blockchain. And so started looking at Monero, which I'm passionate about. And by the way, it doesn't do any smart contracts or anything like that. It's just a token that's private when you move it. It's like Bitcoin with privacy. And so I remember looking at that, but I remember like trying to dig in, like what is the privacy scene about? Like how private do cryptocurrencies get? How do they work? And at the time there was no Zcash, which is reasonable, but not my favorite. There was no Mimblewimble, which is reasonable, not my favorite. Monero's still the king. But like there was like, but there was other things. There was like Verge and other shit coins like that just like had no engineering talent, that were just nonsense. And it is hard to disambiguate, but with enough comments on Reddit and enough YouTube videos, you'll figure it out. So, and if anyone's interested as well, my door's open. I'm on Twitter at John Allen Woods. You can hit me up if you want to just, chat briefly. We can have a little chat, and I can give you my guide on what I think is kind of a good start into Web3.
Awesome. Well, with that, we'll wrap the interview. Thank you so much for taking the time. That was absolutely epic. We covered so many topics, went in deep. Anything else you want to go over?
No, just delighted to be here. Thank you very much for having me. I really appreciate it.
Let's go. All right. Stay tuned for more from Algorand. A lot coming out this next year. You're here to hear first. Make sure to follow John as well as Genzio and Algorand.
Go Genzio.
Cheers. Thank you.
Cheers.